So very good morning to you all. So welcome back to this course on fundamentals of data analysis. And here we are exploring the major topic, exploring data analytics. And in that the subtopic is calculating and interpreting common descriptive statistics. And here we want to talk about percentiles. So let us quickly get into this discussion on this quartiles. Now, this is actually, we have already seen in the last class regarding the quartiles. Now, this is actually how do we calculate the quartiles for ungrouped data. And suppose, for example, if you are in data items, the first thing you have to do this is arrange in an ascending order. And then we calculate quartile 1, quartile 2, quartile 3. So quartile 1 formula is n plus 1 by 4th item absolute value. So there is no negative value is going to come out of it. Q2 is equal to n plus 1 by 2th item. Q3 is equal to n plus 1 by 4th item. So these are the three values. Now let us understand how do we calculate this for an ungrouped data, calculating quartile. So these are the marks of the 8 students in an examinations. We have got 8 values. And let us calculate the quartile 1, quartile 2, and quartile 3 for this ungrouped data. Now quartile 1 is equal to n plus 1 by 4th item. So n is 8 plus 1 by 4. It's actually 2.25. So it is written as second item plus 0.25 into third minus the second item. This is how do we do it mathematically. And we already got the values for the third item because we already arranged in ascending order. 25 plus 0.25 into 29 minus 25, we got 26. The quartile value is just 26. Similarly, the quartile value Q2 is equal to n plus 1 by 2th item, 8 plus 1 by 2th item, 4.5 item, 4th item plus 0.5 into 5th minus 4th, 0.5 into 48 minus 32, 40. So Q2 is equal to 40. Q3 is equal to 3 into n plus 1 by 4th item, 3 into 8 plus 1 by 2th item. So 3 into 2.25, 6.75, 6th plus 0.75 into 7th minus 6th, 52 plus 0.75 into 57 minus 52, 52 plus 3.75, 55.75. So this is actually the quartile 3 for ungrouped data. And similarly, we can work out one more sum to find out the quartiles for Q1, Q2, Q3, and in this ungrouped data, so we can calculate the similar manner. This is actually the height data of actually a set of students. So we can find out the quartiles Q1, Q2, and Q3. This is actually with respect to ungrouped data. Now, let us understand how do you do calculation for quartiles for discrete series, which is grouped data. So below is the data of the age of the years of 543 members, 543 data points belonging to a city, and this is discrete data. So in 20 years, there are 3 members like the 30, 40, 50, 60, 70. We have got various number of members. This is an example of a discrete series. This is again a group data example because we got two, always group data will have 2 series, discrete series and continuous series. This is the discrete series. And how do we do is put the data points in the ascending order and calculate the frequency which is already given and then find out cumulative frequency. So this is how do we rearrange this data in the form of a table. And once this is done, then we can apply this formula. Q1 is equal to n by 1 4th item. So n is 543 data points, 136th item. The 136th item is actually, how do we calculate this 40 is, you go to the cumulative frequency table and find out this 136 is just crossing where in the cumulative frequency table. So up to, if you can see, 40 years, 136th item. It's actually 40 years. It is actually 196 is just crossing that. Okay, so 40 is actually the quartile 1. Like that, the quartile 2 is equal to n plus 1 by 2th item, 543 plus 1 by 2, 272. If we go back to the table and compare, so 272 is 349 is the value just crossing it. So the corresponding data point is 50. So 50 is actually the quartile 2 value. And quartile 3 is equal to 3 into n plus 1 by 4. So 3 into 543 plus 1 by 4th item. So 3 into the 136, 408, 6. So if we talk about 408, then 489 is the value just crossing it. So the corresponding data point 60 is actually the quartile value. So Q3 is 60 years. So we have 3 cutoff points, Q1, Q2, and Q3. which gives an idea of actually the cutoff points within the data set. So with these boundaries, we can actually work out all the points in relation to these three boundary points. And similarly, we can work out one more sum, quartile series or discrete series based on group data, where weight is given and the number of patients is also given, right? And when next we go about the quartiles for continuous series, which is again a group data, Q1 is equal to L plus N by 4 minus E by F into H. This is L by N by 2. And Q3 is equal to 3 into N, L plus 3 into N by 4 minus E by 4 by H. Okay, these are continuous series data. And L is the lower limit of the quartile class. N is equal to sigma of total number of observations in the data set. C is the cumulative frequency in the class immediately before the quartile class. F is the frequency of the quartile class, and H is the length of the class interval of the quartile class. And let us quickly do a small calculation. The quartiles for the wages of the labors. Wages in rupees is given in class interval. Number of labors is given. We rearrange the data in the form of a frequency distribution table where X is actually the class intervals, F is the frequency, cumulative frequency workout. And the same formulas we use, L plus N by 4 into C. We got 21.75. If you talk about 24, want to go back actually, 32 to 34, 30 is the value just crossing it. So 32 to 34 is the quartile class. So we take the lower boundary. Okay, the number of data points remains the same. Then frequency of the particular quartile class, which is F, and then C has already told you cumulative frequency in the class before the quartile class is 30. So in this case, it is 12. So we calculate 33.05. Like that, we can find out for Q2 as well as Q3. So this is how do we complete. Thank you very much for this listening patiently. Thank you very much.